Hey guys, it's Dr. Jansen, and today we're going to talk about graphing linear equations when they're already written in slope-intercept form. So let's get started. All right, so let's look at number one. We know this equation is in slope-intercept form because we can see it's in y equals mx plus b. Beautiful. So we can see that we have our m here right next to our x, which again is our slope. And we can see we have our y-intercept here, our positive 2. We need these. In order to be able to put a line on a graph, it actually has to be in slope-intercept form because we need the slope and we need the y-intercept. If it's not, we would have had to rearrange that equation and then put it in slope-intercept form to be able to pull the slope out and the y-intercept out like we just did from our equation. So now that we have the slope and the y-intercept, we're going to be able to graph this equation. So first, we need to graph the y-intercept. That is always step one. So step one, first, graph the y-intercept. Okay? So what we're going to do with that is it means we're just going to put that y-intercept on the y-axis because that's actually what the y-intercept means. And y-intercept is just where our line crosses the y-axis. That's what this is. This is just the equation of a line. We're just putting that line on the graph. So y-intercept, it's just telling us where our line crosses the y-axis, and it's saying that it does so at positive 2. So we are going to put a dot at positive 2. We always count from our origin right here at 0, 0. So we're going to start here and we're going to go up 1, 2. I'm just making those little bubbles to show you where I'm counting. I'm going to get rid of them now and I'm going to put a nice big dot that's easy to see at positive 2 to show that that's where we're going to start counting our slope for this line. So now our slope always needs to be a fraction. Here it's just a 3. But again, we've learned that anytime we have a whole number, it's the same as that number over 1. So this 3 is really the same as 3 over 1. Our slope is always rise over run. And even though we say rise, that really just means moving up and down. Up and down. So even though we're saying rise, it could actually be drop, okay? So if there's ever a negative, it says rise, -1, it really means just drop 1. So we have rise is what we're always going to do first with the number on top, and then run just means move side to side. So again, right now we're talking about 3 over run. So we're going to start here at our y-intercept, and it says we are going to rise positive 3, and we are going to run positive 1. The signs of those numbers are incredibly important because if one of them would have been negative, we would have needed to move in the other direction. So paying attention to whether that 3 was positive and that 1 was positive was really important here, okay? So again, I'm going to go back and get rid of the lines that I drew. I was just showing you those to show how I was moving. I'm going to go back and just draw my dot. From there, we always use a ruler. This is so important. We need to use a ruler to make sure that we're super precise. Here, I can't use one on my iPad, so my lines are not going to be great, but I'm going to do my best to draw them here. And from there, we would use a ruler to draw our lines. I know mine's a little wiggly, sorry. And we would draw our line, okay? Again, that's not beautiful. You would use a ruler. It would look much prettier. And this graph is also really small because I just don't have much room on my iPad. But if you could, you would actually, if you had more room on your graph, I would say you would keep rising and running 3 over 1, 3 over 1 as much as you possibly could to get the most accurate line. But we never go off our graph if we run out of room. So like I'm obeying that rule. I don't have any more room on my graph, so I'm stopping. But if you have more room on your graph, keep going because it'll help you have the most accurate line you can. Okay, so let's do another one. I'm going to write it right here. Number 2. Okay, y equals 1/4 x minus 5. Okay, Again, these equations we're dealing with today are already in slope-intercept form, thank goodness. So we are able to just very easily pull out our slope and our y-intercept, as we've already done in the previous lesson. So here's our slope. Here's our y-intercept. Remember which one we do first? It's our y-intercept. Okay, so we're going to graph this one first. In this one, it's at -5. So again, starting here at the origin, I'm going to count down 1, 2, 3, 4, 5, and put my dot there, down at -5. And next I'm going to do my slope, which is rise over run. This one's already in a fraction, so it's nice and easy. They're both positive, which again is super important because it tells me what direction I'm going to move. So again, starting here at my y-intercept, I'm going to rise +1 and then run +4. Again, I run out of room on my graph to keep doing that, so I've got to stop just at that one. Rise there, run there. I'm going to get rid of that line, and I'm just going to put my dot. I'm going to draw the best line here that I can. And that is going to have to do, but you are going to use your rulers and it's going to be so beautiful. All right, I got 2 more for you here and then we're done. So let's look at number 3. This one again, beautifully in slope-intercept form. So we can pull out our slope right here. Whatever is right next to our x that's being multiplied by x is our slope. And then whatever's far off to the right here, always including its sign, is our y-intercept. Again, we're going to graph our y-intercept first. It's +4, counting from our origin. Again, it's always on the y-axis here. 1, 2, 3, 4, and we're going to put our dot right there. And then we're always going to count our slope from our y-intercept. Let's look at our slope. Okay, so here our slope is a little unique. We have a negative in front. And actually, I'm going to erase this negative. I wrote it a little close to the 2, but a lot of time you see the negative written straight in the middle of your fraction like that. And people always ask me, Dr. Jeanson, does the negative apply to the top or the bottom or both? If you ever see a negative written like this, my trick is always just to apply it to the top number. You cannot apply it to the top and bottom because if you did that, if you did -2 divided by -3, a negative divided by a negative is a positive, and that would make the whole thing positive, which is not what this says. This says that it's a -2/3. And if you don't believe me and you're not great with integers, punch that in your calculator, it'll come out to be positive. So you can only apply that negative to one number. I think to make it easy, I always just apply it to the top number. And so leave the bottom positive, make the top one negative, and that's what I always do. So what we're going to do is we're going to make that -2 over +3 for our rise over run. So rise over run. So starting at our y-intercept, as we always do when we're graphing equations, starting at our y-intercept of +4 that we already graphed, we're going to drop 2 because again, remember I said rise is really just moving up and down for our slope. So even though it's rising -2, we're really just dropping 2. So I know you can't really see it because I'm writing it right here over this black line, but we're dropping -2 and then running +3. And that's where we're going to put our dot right here. And we're going to drop 2 and run +3. We still have a little bit of room on our graph to be able to do that twice, which is awesome because it's going to help us have a super accurate line. It's just going to help it to be even straighter. You guys are using rulers out there, so it's going to be really beautiful. And you can even see how mine looks a little neater with an extra dot. So there you go. So let's do one more. And for those of you confused about why we're moving positive or negative, on the x-axis, this is positive, this is negative. On the y-axis, this is positive, this is negative. I realize I didn't really say that in the beginning. All right, number 4, last one, y equals -x minus 3. Okay, so here we are looking for our slope, but there is nothing in front of x. Whenever there's nothing in front of x, that's a lie. There is always something in front of x, and that is our dear friend 1. So our slope here is -1. And then our y-intercept is -3. Again, we always graph that y-intercept first. Make this line green. And so we start always at our origin. We're going to go down 1, 2, 3, because again, we're graphing our y-intercept, -3. Awesome. So now let's go to our slope. Again, it's got to be rise over run, so it's got to be a fraction. Well, I know I just have my whole number of 1, but I know I can turn any whole number into a fraction by putting any whole number just over 1. So I've got -1 over 1, so there's my fraction to be able to graph my slope. Starting here at my y-intercept, as I always do, I can drop 1, down 1, because I'm moving in the negative direction on my y-axis, and then running +1, moving in the positive direction on my x-intercept, or not x-intercept, excuse me, x-axis. So down 1, +1, and I could do that again because I still have a little bit of room on my graph. So I can graph these 2 dots, draw my line. Again, you guys always use a ruler, and there we go. So we graphed several lines here, and hopefully you got lots of different examples as to how to graph linear equations when the equation is in slope-intercept form. Remember, if it's not, you have to put it in slope-intercept form, and we did that in the lesson right before. So great job.